The name of this talk is Language Unleashed, an overview of NLP. So from this talk, I want you guys to walk with a gist, a flavor of what natural language processing is. So I'm not going to be teaching you any specific methods or models, and you're going to go and code them. I just want you to give you an intuition of what's happening under the hood behind these models that are so famous and popular nowadays. So let's kick it off. So I always include a slide to introduce myself, but Eric did such a great job, so I'm just gonna skip it. But if anyone wants to connect with me on LinkedIn, that's my LinkedIn, and I'll put it again at the end of the talk. So let's just start with a little quiz. I mean, it's not a quiz. I'm not gonna grade you guys, but it's a Google form. I'm gonna put it in the chat. So I'll put it here in the chat. Also, if I'm looking to the side, it's because I'm looking to the chat and your faces. So I want to ask you guys, what does NLP stand for? I think we already gave you spoilers for that. And I also want to ask you if you have used NLP today. So natural language processing. Google clearly needs a better tokenizer because this should have been a single response, but that's awesome. All of you get A plus. And then, have you used NLP today? So we have 68% of people, or 65 saying yes, 25% said no. And then 9%, or well, the percentages are changing, but you guys are seeing it, says, I don't know. So the purpose of this talk is that the plot twist is that everybody in this room has used NLP today, even unless you just came out of a retreat in the middle of nowhere, but chances are that you have used NLP. This is why I made this question, because I see someone right here that said neurolinguistic programming. So if whenever you Google something about NLP, make sure you're reading something about natural language processing, if that's what you want to read about, because NLP could also stand for neurolinguistic programming. So I'm very happy that someone responded that. What is natural language processing? So let's just start with natural language. And maybe this is the ESL, like the English as second language speaker in me. But when I first heard natural language, I was like, what is that? It sounds fancy, but what is that? And it's just simply any language that humans use to communicate with each other. So in this case, in this room tonight, we're using English. So English is the natural language that we're using tonight. At home, I use Spanish, and at home, maybe some of you use Portuguese, the person that joined from Brazil, and yeah, different languages that you speak at home. So that's all that natural language means. And then natural language processing is the field within AI, artificial intelligence, that deals with human languages and derives valuable information from them. So I do want to highlight that NLP is not a method, is not a technique, it's more like a field that has dozens of methods and strategies to solve any given problem that has text, that has natural language. So that's where the name natural language processing comes. And then the question is, why learn NLP? So fun fact, there are more than 7,000 spoken languages in the world. I only speak 3 of them. So I feel like every time I learn a new language, I feel like I open a new door to a new world, to a new set of knowledge and a new set of people. But I'm missing over 7,000 of them, and I'm probably not going to learn 7,000 languages, but I'm happy that I have AI to help me open those doors of knowledge that are out there just waiting for me to gather that information that is available in other languages. Also, another important point is that approximately 80 to 90% of the data generated and collected by organizations is unstructured, and most of that unstructured data is in the form of text. And just think about it, there's millions of data that are being generated right now, either through WhatsApp, Twitter, YouTube, Reddit. There's comments everywhere, people are publishing articles everywhere, blog posts, etc. So there's a lot of data out there that even if we hired a human and we told him, your sole purpose in life is to read everything out there, and you just give us the summarization of it. Just give us insights of what is important. Someone fully dedicated to that wouldn't be able to do it. Even if we got a group of humans solely dedicated to that, wouldn't be able to do it. So that's why it's important to learn NLP, to be able to gather all those wonderful insights that are out there ready to be discovered and understood by us. So going into some examples of NLP in the real world, this is where we'll see that probably, most likely, all of you have used NLP today. So the first example would be language modeling. And this happens whenever you go on Google and you write something on the search bar, and then the search bar gives you more recommendations. So for example, in this case, I was searching for why do cats, and then it showed me why do cats purr, why do cats make biscuits, etc. So basically what it does is to predict the sentence based on the history of previous words. The same thing you see it whenever you write an email. For example, I use Gmail. So on Gmail, I type something and then it suggests how to end my sentence. That's language modeling right there. So if you have used that today, you have used NLP. The second one is NLP in the real world. The second example is text classification. So basically what this does is to classify text in different categories based on its content. The most famous example that I'm sure probably all of you have used today, if you have an email account, is to be able to detect if a given email is spam or not. And then when we go into text classification, there are different ways to approach it. So we have binary text classification. So for example, is it spam or not? But we also have multi-class classification if you have more than 2 categories. And we also have multi-label classification where a single item could have multiple labels. Another example of NLP in the real world is information extraction. So as the name implies it, this refers to extracting relevant information from the text. So if you use WhatsApp and you send a message to someone and you say like, would you be able to meet me tomorrow at 5 p.m.? WhatsApp automatically highlights that part of tomorrow at 5 p.m. And when you click on it, you can create an event. That's information extraction right there. So basically, anytime that you want to extract any relevant entity that is being mentioned in a text. The second example is information retrieval, which is how Google made the big bucks back in the day, because they were able, so Google is constantly crawling the web and getting like an archive of everything that is available in the web. But the second task that they do is that they show you relevant information, because it would be basically worthless if they were aware of everything that is available in the web, but they wouldn't be able to show you relevant results. So with information retrieval, search engines like Google are able to find relevant documents in a large data set based on an user's search. And this is, of course, closely related to text summarization, because you want to know what a given document is talking about. The next application is chatbots. So whenever you go on a website or you go and try to talk to your bank or to your airline, usually they have a chatbot, and it's systems that answer questions automatically. You're not talking to a human, you're talking to a bot, and they usually can solve your problem. And then if not, they'll send it to a human. So that's also NLP in the real world. Translation, this is one that I use all the time, either with Google Translate or deepl.com, just to go from one language to the other. This case of NLP in the real world, I think, is the one that excites me the most about. So I'm going to be showing you a little video about it. But basically, what social media monitoring does is that companies want to be able to understand their customers, and they want to know what they're talking about, what are their needs, so they can create targeted marketing campaigns. And with targeted marketing campaigns, they can just make more money. So they want to be able to take advantage of all that information that is available on social media. And this is a wonderful example how a data scientist can make a huge impact on a company. So let me just show you this YouTube video real quick.
Tell me about Jamba Juice.
Tell me about Jamba Juice.
We have something similar in Britain.
We have something similar in Britain.
We call it a swishy chug.
Swishy chug is called in English.
Swishy chug. Say it.
Swishy chug.
Say it. Swishy chug.
Swishy chug.
Swishy chug.
Swishy chug.
Swishy chug. Swishy chug.
How did we turn a prank into an idea to promote our smoothies without a budget?
Obviously, there's no such thing as a swishy chug. And after it aired, this website appeared. It's swishychug.com. It says, move over tea and crumpets. England has a new national favorite, the Rolling in the Beets smoothie. And when you click on the coupon, it takes you to Jamba Juice, a website for $2 off any smoothie. So very cool. So Jamba Juice put that overnight. They put that up. And I love that they did that. I mean, that's a fantastic ideas.
Thank you, Ellen, but it didn't happen overnight. It was faster. We picked up on the prank the morning it happened. And by the time the segment aired in the afternoon, we had built the Swishy Chug brand from scratch, complete with a logo, a website, a coupon, and a Twitter handle. We even launched 5 signature smoothies inspired by Adele. Within seconds of the broadcast, the internet lit up with conversations about Jamba Juice and Swishy Chug. We jumped in and took the opportunity to promote our smoothies through tweets and response videos. Our engagement went off the charts. In just 4 days, Jamba Juice was featured in over 1,200 publications, which led to an internet-breaking number of impressions, generating over $10 million of earned exposure. As a result of the campaign, 120,000 coupons were downloaded and sales soared by 32%, while we spent $0 on media. In addition to promoting our smoothies, we created a conversation around the brand and brought it to life. While Swishy Chug may not be real, we found that the power of an idea certainly is.
So very impressive, no? It's wild how a group of data scientists, so just to give you some context, the advertising agency behind Jamba Juice that manages all their marketing campaigns is Zimmerman Advertising. So I used to work for that company. This happened before I joined the company. I would have love to be part of that when that happened, but that happened before I joined the company. But basically, because the data science team was constantly monitoring what people were saying online about Jamba Juice, when the opportunity came that a worldwide celebrity like Adele visited your store and you were able to react on real time on the spot, they made $10 million in exposure. So if they wanted to grab that much exposure through social media and magazines and news and etc., they would have had to spend $10 million, but they spent $0. So literally the group of data scientists gained $10 million to this marketing campaign. To me, that feels like an Emily in Paris moment. So that is just to show how powerful data science can be. So that's one of the examples of how NLP in the real world works, social media monitoring. This is like personally my favorite, but let's just keep looking at other examples. So of course, you guys are probably going to think about other examples. These are just a few, but this next one in particular, I like because it's about how we can understand the world better. New things that arise, we can understand them better through NLP. So this is an emoji analysis by Instagram. The analysis is a little bit outdated. It's from 2015. But when emojis became a thing, we didn't know what emojis meant. Sure, we can see that a sad face is a sad face, but there are some other emojis that are ambiguous. And also people use emojis in different ways. And this is what they discovered. So for this, we see the relationship between emojis. And by the end of this talk, hopefully you're gonna have a better grasp of how these plots are made. But basically each emoji is placed in space related to the other emojis in meaning. So here we have all the happy faces, just like faces in general, not just happy. Over here, we have the vegetable and fruits, which makes sense because people are probably talking similarly about vegetables and fruits. However, there's a set of 2 fruits that are not with the vegetable and the fruits because people don't use the peach emoji and the eggplant emoji like the vegetables emojis. So I thought it was fun that they were able to see that quantitatively, because if you don't know what people are expressing through emojis, you can just run an NLP analysis and see what people are given, what meanings people are given to the different emojis. So I thought that was pretty cool. And now another example is the virtual assistant. So someone said on the chat that they spoke to Alexa today. And I also spoke to Siri, but I was wondering, how do we talk to Siri? So Siri speaks English. In reality, they don't. They speak binary, so they understand ones and zeros. But the beauty of NLP is that it allows that bridge between natural languages and the binary representation. So how do we do that? Let's just think about other types of data. So to be able to teach anything to a machine, you have to represent it in a numerical form. So if we wanted to, if this was not natural language processing today, but we were talking about computer vision, we will be talking about this. So here on the left, we have a nice image about some cute corgis, and that's what we see. But what do computers see? The computers see this matrix over here. So basically an image is represented on a computer in the form of a matrix where each pixel is represented in the matrix in the cell ij. So in the cell ij, you have the value of that pixel of the image, the pixel ij of the image. So similarly, a video is a collection of frames where each frame is an image. Therefore, any video can be represented as a collection of matrices. Unfortunately, representing text numerically is not so simple, and we're going to see why it's not so simple. And I put the unfortunately in parentheses because to me that's fortunate, because that's why I have a job and that's why I'm giving this talk. So we'll see what are some of the fun challenges that we face with NLP. So why is it so hard? Let's look at this sentence, and I would love it if you guys can write in the chat. I saw the man on the hill with a telescope. What do you guys think about this when you see this sentence? Like, what are you picturing in your mind? Oh, Jason is giving us spoilers. That's where I'm heading towards. So Jason is in the first thought that Jason had in his mind is that there's a man on a hill with a telescope. So I saw that man on the hill with a telescope. And then Jared is asking us, does he have a telescope or did I see him through the telescope? Exactly. So these are the 5 meanings that, let me just show it to you. So these are the 5 meanings that people have come up with this sentence. And I'm sure if we looked at it long enough, we could come up with more meanings. But basically, I saw the man. The man could have been on the hill and I was using the telescope to see the man. Or I saw the man and I was on the hill and I was using the telescope, but the man was not on the hill. Or I saw the man was on the hill had a telescope, which will be this 3rd image right here, or the 4th one, which is I saw the man, I was on the hill, and the hill had a telescope. But I was not using the telescope. And then the 5th one would be I saw the man was on the hill, and I saw him using a telescope. So there are many, many, many ways to interpret this sentence. And if it's hard for us as humans, now imagine how hard it is for machines. Another example, I want you guys to tell me what do they mean in each sentence. So the first sentence is the city council denied the demonstrators the permit because they advocated violence. And then the second sentence is the city council denied the demonstrators the permit because they feared violence. So in this case, we can see that in the first sentence, it means demonstrators. Or it depends, or it could be the city is the one that is advocating violence. So who is they? So from my context of life, I assume that they in the first sentence was the demonstrators, and then on the second one was the city council. But it could very much that the ones that feared violence were the demonstrators. So that goes to say that it's unclear, even though it's exactly the same word. So if they could, like, if we wanted to represent this word with a single numerical character, we wouldn't have success because they don't refer to the same thing, even though it's exactly the same word. More examples. Is the chicken ready to eat? So does that mean that someone in my household could cook that chicken and I'm gonna have dinner? I'm gonna have chicken for dinner, or I just happen to have a pet chicken and I'm ready to give it food. So there's a lot of ambiguity, like, for example, those 3 examples that we just saw. Some other challenges: the dog bit the man versus the man bit the dog. So from common knowledge, I know that even though both sentences are grammatically correct, the one that is most likely to happen is the dog bit the man. Unless you live in Florida, maybe you have the man bit the dog. But we have to take into account that common knowledge is very important to be able to get that context of text. Next example, how do you say homesick in Spanish? Actually, there's not a word for homesick in Spanish. You could say something like, I'm nostalgic about my home, or I'm nostalgic about my country, but homesick, as it is in English, it doesn't exist in Spanish. So we have a lot of language diversity. And for you guys, oh, well, I don't know, we have many people in the room. So for the people that work in English, that's fine. Luckily for you, most NLP models are trained in English. But if you're someone like me that I work with data sets in Spanish, or I bet whoever lives in Brazil works with data sets in Portuguese, it's a challenge because English is not exactly the same as Spanish, or even if you speak a more a language that is significantly more different than English, I don't know, like Greek or Russian, you're gonna face those challenges because usually models are trained in English. Another issue is, for example, let's look at Homer. Homer is saying like, I'm the magical man from the happy land, etc., etc. And then he comes back and says it's sarcasm. So I don't know about you guys, but I have a hard time knowing what's sarcasm and what is not. So imagine trying to teach that to machines. That's another challenge that we face with NLP. So now we have grasped why NLP is hard. And let's go back to the representation of data in numerical form. So we have text, and text is data, but how do we represent it in a numerical form? That way we are able to communicate with machines and we can extract the value from all that text that is available. So the issue at hand is that even if you have the best model in the world, if you put garbage in, you get garbage out. So if your data is garbage, your results are going to be garbage. So you have to pre-process this data in a way that is meaningful, that makes sense, so your model can perform and do and have good results. So let's take as an example the word bow. So can we just give it a number to represent it? Why don't we just say bow is the word number 23? And whenever we see the word bow, we're just going to use number 23 to represent it. That wouldn't quite work because, for starters, bow could mean the gesture, or bow could also mean just like a nice ribbon. So using the same number wouldn't work. But also, you're missing context. People could also have a spelling mistake, etc. So there are many challenges that just giving it a number wouldn't cut it. But then how do we represent the meaning of a word? And we have to take a step back and ask, how do we humans know what a word means? Because as much as artificial intelligence helps us, artificial intelligence is just an extension of our brain. So anything that our brain is capable of doing, the artificial intelligence is just going to be able to do it faster and on a bigger scale. But if we're not able to do it with our brains, probably the AI is not going to be able to do it. So that's a beautiful thing about how we get inspired from psychology, neuroscience to implement these models into AI. So we have to ask ourselves, how do we humans know what a word means? So for example, if I say the word queen, many of you are going to start having images in your head. So depending on where you're from, you might be thinking of the British royalty, or maybe you're thinking of the Romanovs, or you're thinking of just tiaras and cute dresses. I love beauty pageants, so I'm definitely thinking of Miss Universe and Miss World and Miss International. But in the end, we all learn through experience, and all those images that we have in our head is because we've gotten them through experience. So surprisingly enough, machines can also learn through experience. And this is a major spoiler of the talk, because machines learn through experience. And basically NLP, what it does is that it just consumes tons and tons and tons of text until machines are able to understand the meaning of words. And we're going to see an example about that. So what is meant by the meaning of a word? And I know I'm starting to sound repetitive, so let's just go with an example. Don't use Google. What is tichiniki? And if you don't know what tichiniki is, just feel free to write in the chat. I don't know what tichiniki is, or like I've never heard of it or anything. So have you guys heard of it? Does anybody know what it is, or no clue? Don't know, never heard of it. Okay, cool. So I'm not going to tell you what tichiniki is, but I'm going to just say some sentences right now. So Joseph offered a glass of tichiniki to his girlfriend. Tichiniki and steak make a great pairing for a nice meal. Charles stumbled, his face flushed from drinking too much tichiniki. Last night, I had bread, cheese, and this excellent tichiniki for dinner. So now I ask you again, what does tichiniki mean? Everybody's saying wine in the chat. Someone said fortified beverage, alcoholic drink. Din, 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 alcoholic drink. Points for Dylan. So it is an alcoholic drink. Did I tell you it's an alcoholic drink? I never did that. But just by using it in context, you guys knew what tichiniki was. And that's basically how we learn languages as we're growing up. So that's what is called distributional semantics. Let's look at these sentences, and I'm going to do another example. So we have a bottle of tichiniki is on the table. Not everyone likes tichiniki. Don't drink tichiniki and drive. We make tichiniki with grapes, etc. So what other words would go well in this context? So I brought some words here for us to work on, and I left the spoilers on. So let me just turn off the spoilers real quick. So basically, we're just gonna fill this table together. Okay, one more. Okay, now one more column. Okay, so we have this empty table, and the way it's gonna work is that for the sentence one, we're gonna read for each sentence the word and see if it makes sense. We're gonna give it a 1, and if it doesn't make sense, we're gonna give it a 0. So for tichiniki, so a bottle of tichiniki is on the table. It makes sense, so we're gonna give it a 1. Not everyone likes tichiniki. I'm gonna give it a 1 too. Don't drink tichiniki and drive, also 1. And then we make tichiniki with grapes. Also, I'm gonna give it a 1. Now let's go with the word strong. So a bottle of strong is on the table. Does that make sense? No. So let's just give it a 0. Not everyone likes strong. That sounds awkward. Don't drink strong and drive. That sounds funny. So that's a 0. We make strong with grapes. Yeah, that also sounds funny. So we're gonna give it a 0. So now let's go with motor oil. A bottle of motor oil is on the table. That makes sense. So let's just give it a 1. Not everyone likes motor oil. As much as that makes sense grammatically, chances that we're going to see that sentence are low. So I'm just going to put 0 in this case. Then don't drink motor oil and drive. I hope nobody's doing that, but that also sounds weird. Like we're probably not gonna see that sentence that often, so I'm just gonna give it a 0. And we make motor oil with grapes. No. Tacos. A bottle of tacos is on the table. Tacos don't come in a bottle, so 0. Not everyone likes tacos. That could be it. So 1. Don't drink tacos and drive. We don't drink tacos, so that's a 0. And we make tacos with grapes, unless it's a very special type of tacos that I haven't had before. That's gonna be a 0. And then wine. A bottle of wine is on the table. Yes, so 1. Not everyone likes wine. That would be a 1. Don't drink wine and drive. That would be a 1. And we make wine with grapes. That would also be a 1. So what we just did just now, it's a vector representation. So let's notice that tichiniki and wine have the same vector representation. So they have tichiniki is 1, 1, 1, 1. And this dummy example is a very small example. And wine also has the same thing. If we had come up with more sentences, at some point we might have seen some difference, because tichiniki and wine are not the same thing, but they're very similar. So even though they're not the same word, the same item, they will be close together in space because their vector representation is very similar. In the other hand, if you look at columns, for example, column 1 is for this sentence, the sentence of a bottle of blank is on the table. We can see that maybe that column is giving us the meaning, quote unquote, the meaning of something that could be in a bottle on top of a table. So something, maybe a liquid, something that can be in a bottle. So we see that tichiniki, motor oil, and wine applies. They all apply for that definition. Of course, when we're doing this with a bigger data set, it's going to be harder to infer the meaning because there's just going to be so many words and so many documents, but that's the intuition behind it. So just some common NLP terminology in case you want to impress your friends and family members at your next party. We have token, so a continuous sequence of characters. The most common example would just be a word, but we could also have emoji or punctuation, etc. We have documents. So document is just a collection of tokens. So for example, a Wikipedia article would be a document in our data set. Then a corpus is a collection of documents. So for example, all Wikipedia articles. And if you've hearing corpus for the first time ever, this word in this context, you're going to start hearing it over and over and over again, because whenever those big companies release any new NLP model with a corpus, that's what they refer to. Like, what was their training data? What documents they used to train their models? That's what they refer to when they use the word corpus. And then embedding is just a numerical vector representation of text. So for example, for each word, each token, we can have a numerical vector representation of it, which is basically what we just did right here. This is an embedding. So once you have a numerical vector representation, you can do something that I'm very, very excited about: math. And I'm excited about it because I'm a mathematician, so I love math. But you can do really cool things once you have that numerical vector representation. So for example, you can take the meaning of man, which would be the embedding of the word man, minus the meaning of king, plus the meaning of queen, and then you get women. So basically, Michaelov and his team in 2013, they came up with this. And basically, their conclusion is that neural networks can make machines understand analogies like humans, which was a huge step in the world in NLP because it allowed us to do cooler things. So of course, this wouldn't be a coding talk and data science talk without any code. So let's just see a small example here. Here I'm just importing some libraries. Here I just have a small function. You don't need to worry about it. Just basically, I wanted to be able to give it 3 words. So word A is to word B, as word C is to So we're gonna run some examples there. I'm using the corpus provided by Google News. So basically, Google just grabbed a bunch of news articles and trained their corpus on that. Since news are all over the place, you could have sports and you can have technology and political science, etc. In theory, you should have most of the words in the English language in a broad sense. So let's just try the analogy that I was just saying, and drum roll. The drum roll lasted longer than the code, too fast. So king is to man as queen is to woman. So let's just try something else. So Colombia is to Bogota as France is to, and I hope you all know geography. Some drum roll, and we have Paris. So Colombia is to Bogota as France is to Paris. But what happens if I try USA? Does anybody want to guess in the chat what happens if I try USA? Colombia is to Bogota as USA is to. So Jason says Washington, D.C. Let's see. Market, it says New York. So it says New York. So something that I want to highlight with this is that these are not facts. These are not like truth statements. It just looks at how people talk about things and makes analogies. So in the case of the United States, even though the capital is Washington, D.C., New York is much more bigger. It's a huge financial and technological center. It has many cultural activities. So probably people are talking a lot about New York in relation to the US. As the same way as Bogota, people talk about Bogota in Colombia, where Bogota is the capital of Colombia, but it's also its main city. And same thing will happen if we do Brazil. So if we do Brazil, the capital of Brazil is Brasilia, but it says Sao Paulo because Sao Paulo is basically the New York of Brazil. So same thing happens. So this is just to highlight that these are, and we have to be very careful about this, that these are not facts. It's just what the machine learning learned through context. And we'll see why later on this is important. But now we're gonna see what are the most similar words to a given word. So for example, we have game, the word game, and we compute the Euclidean distance or your favorite distance from all the other words in the corpus, all the other tokens, I should say, since we already learned that word. So all the other tokens in the corpus, and we just show the words with the that are the closest to game in distance. So we'll see. So this corpus is a news corp from just different news articles. So it's just like standard English language. So we see the most similar words to game are games, play, match, matchup, a game, ball game, the game, opener, matches, tournament, etc. But what happens if I train it on a data set that is rap music? So lyrics of songs that are rap. And I will show you a sample of the data set, but as I was checking my slides, I realized they have bad words and not even this profanity library was able to hide all of them. So I'm not gonna show you the data set. But basically what I wanna do is that now that I have trained this new model on the corpus of rap lyrics, what happens if I try to find the most similar words to game? We find shame, fame, name, aim, remains. So things that rhyme with game because it's rap lyrics. And same thing with so if we go back and we look at the ones by Google, so the ones by Google is game, play, match, matchup, a game. So that's just to highlight how important is that you choose a good corpus, and you can use this to your advantage. For example, if you work in the medical field, you can train your model on a medical corpus, and then that's going to allow you to do a better analysis of your data. However, this is a good time to do a little bit of reflection, because as data scientists, we have to be aware of all the different biases that are out there. So one controversy that happened when Word2Vec came out is that people were finding interesting analogies. So for example, it would be man is to doctor as woman is to blank. And so instead of saying doctor, it would say nurse and things like that. So, and it's not like there was someone on Google creating this corpus and they were like, let's just be biased and evil. Okay, I'm too excited with my stream deck, but it's just that that's how people talk on the internet. That's how historical data has been written. So all those biases are there. But as data professionals, we have to be very conscious of these biases because sure, you can be maybe working on a not so relevant model about predicting sales at some store. So it doesn't matter if you predicted more sales or less sales than what it actually was. But you could be working at a bank deciding if people should get a loan or not. And if your data set has all these biases, you might be prohibiting people from the opportunity to get a loan and then start their own business and get out of poverty and things like that. So it's very important that we think about data and the implications that it has and how we can work towards a better world. It's a difficult task because we all have biases and it's hard to notice them. There are biases for a reason, but the first step is to know that we all have biases so we can as a data professionals try to work towards a more fair world. So if anybody is interested in this topic, I recommend this book. It's called Weapons of Math Destruction by Cathy O'Neill. It's pretty good. So I know that we're running a little bit out of time. So I'm just gonna quickly breeze through the evolution of NLP, and then I'm just gonna open it for questions. So the evolution of NLP, as you can see it, I think these are the four most important things that have happened. So in the 1950s, we started with bag of words. It was a very simple technique to generate text embeddings. Basically, it was counting words. And it's still used. It could give good results, but not good enough. Then later on, TF-IDF came about, but it was not until 2013 when Word2Vec came out with the analogies that this field really took off, and now we're seeing all those interesting developments. So Word2Vec is just a technique that takes into account the semantic relationship between words, and it was one of the first models to use neural networks for this purpose. And now we're seeing a bunch of exciting things with transformers. Since 2018, we see transformers, GPT, BERT, GPT-2, Rovera, GPT-3, GPT-4 is about to come out. And those are models that use attention to increase the speed of task-specific training. That is just to say that we're in an interesting time where we have so powerful tools that are so powerful, like ChatGPT. I actually picked the title of my talk using ChatGPT, so that's why it's Language Unleashed. ChatGPT told me to name it like that. But what I want to say is that we're entering into a world that has a lot of deep fakes. We are relying more and more on data, so it's important that we have data literacy. Even if you don't work in the data science field, it's important to have data literacy. And if you're a data scientist or a data professional, just do good and reach out to your friends and your family and just try to teach them a little bit so they have a better understanding of the world. I think that's very important, how we're understanding the world nowadays. So that would be the end of my talk for now. I wanted to thank Codesmith for the invitation and for all of you for being here. And I hope that we stay in touch. I'll give it back to Eric.
Thank you, Viviana. That was amazing. Thank you so much.